travels at 99% the speed of light.
That canister contains an extremely combustible substance called antimatter. We need to locate it immediately.
This is the most violent thing we know about. Let's talk about antimatter.
In 2009, there was a movie called Angels and Demons. The film tells the story of a terrorist group called the Illuminati that plans to blow up the Vatican using a bomb made out of antimatter. Now in this video, we're not going to talk about the Illuminati because that probably falls into conspiracy territory. You already know how it goes. We're focusing on the science. So in this video, we're going to talk about antimatter because antimatter itself isn't fiction.
And to you, antimatter might sound like science fiction, but what I want to get over to you in this talk is that antimatter is science fact.
Just like the name suggests, antimatter is the antithesis or the opposite of matter, something that emerges from the existence of matter itself. But strangely, this antimatter is also what can ultimately destroy matter. And what's even crazier is that once we start talking about antimatter, it takes us all the way back to the very first seconds of the universe, to the moment that we know as the Big Bang.
You're talking about the moment of creation.
Yes.
In other words, we want to know exactly what it is about antimatter that made evolution of the universe happen. This is why it's a big mystery in physics.
Later, you'll see that antimatter almost destroyed the entire universe from the very beginning. But the universe survived that destruction because there was a flaw in the mutual annihilation process. Wait, what does that even mean? Almost destroyed the universe? A flaw in the annihilation system? Yeah, that's basically what this is about. So get your brain ready, because in this video, we're diving into one of the most absurd regions of modern science. Let's talk about it. Alright guys, before we get into the heavy part, let's start with the story from Angels and Demons. In the movie, a group of scientists who call themselves the Illuminati plan to destroy the Vatican by detonating a bomb filled with antimatter, where they supposedly stole the antimatter bomb from a lab called CERN. Their motivation for destroying the Vatican was revenge, because in the past, religious authorities had opposed many scientific ideas, labeling them as heresy and contradicting faith. The movie even suggests that Galileo was part of the Illuminati and was punished for saying that Earth is not the center of the universe.
Galileo laid out his theories about the Earth revolving around the sun.
It said the Earth was not the center of some universe with heaven above, hell below, as the church had said it was.
So they forced him to recant in the second book.
Okay, let's put all that aside for now. The Illuminati, the revenge, the Vatican, the religious conflict. Now, we're going to focus only on the parts that are actually connected to real-world science. First, we'll talk about antimatter itself. How can the antithesis of matter even exist in a universe that seems to be filled with matter? From there, the discussion connects to a second topic, the origin of the universe. Because in Angels and Demons, antimatter is portrayed as something that helps explain how the universe might have been created in the first place. And third, the idea of antimatter as a bomb. As dramatic as it sounds, antimatter can actually release an enormous amount of energy. Alright, let's start with the big question. What exactly is antimatter, and why does it even exist? At first, the concept of antimatter came from a physicist named Paul Dirac. In 1928, Dirac was trying to create a quantum equation like Schrödinger's, but one that also followed Einstein's theory of relativity. And after going through many complicated equations, Dirac eventually arrived at one final equation. We know it as the Dirac equation. And honestly, guys, I can't explain the full step-by-step derivation of this equation because it's insanely complicated. Our heads would probably explode before we even finished going through all the math. But the point is, from this equation, Dirac predicted something that at the time felt very strange. Here's a simple illustration. If we have an equation like x squared equals 25, then there are two possible values for x. It's either 5 or negative 5, right? Well, Dirac's equation gave a similar kind of result. The equation suggested that there were two energy solutions, positive energy and negative energy. And this solution just didn't make any sense. How could energy be negative? From there, Dirac interpreted the negative energy solution as antimatter.
This is exactly the problem that Dirac faced when he made his theory. He got things that had negative energy. Okay, what he found, these solutions were antimatter.
But was antimatter actually proven to exist? And the answer came in 1932, when a scientist named Carl Anderson was studying particles from cosmic radiation using a cloud chamber. In his research, Anderson found a strange particle track. The particle had the same mass as an electron, but it moved in the opposite direction. And it was an exact match with what Dirac had predicted. The particle was later named the positron, a positively charged electron.
This, the red trail at the bottom, is a positively charged electron. The exact mirror image of the regular negative electron. It's an example of antimatter. This is antimatter. It's as real as the electrons are real.
From that moment on, the theory of antimatter shifted, from being just a mathematical solution in an equation to becoming a real, observable object. Now, in modern physics, it's understood that when matter and antimatter meet, they will annihilate each other. And if we refer to Einstein's most famous equation, E equals mc squared, we know that the mass of that matter and antimatter is converted into energy. Now let's flip the logic. If mass can turn into energy, then energy can also turn into mass. That means under extremely high energy conditions, energy can turn into mass, and that mass appears in the form of particles, which we understand as matter. And if we go back to Dirac's equation, we find something even more interesting. What forms from that energy isn't just matter, antimatter forms as well, at the same time. In other words, energy can turn into matter and antimatter together, in pairs and in equal amounts. I know it sounds strange or maybe even counterintuitive, but again, Einstein and Dirac showed that this is how the universe actually works. And this is the scenario scientists believe happened in the first moments after the Big Bang. Okay, at this point, some of you are probably wondering, if matter and antimatter were created from energy after the Big Bang, then how did the Big Bang itself happen? Well, that's a deep and complex topic. We'll save that for a separate video. But the key point is that after the Big Bang, the universe was filled with energy, and from that energy, pairs of matter and antimatter emerged. And underline this part, matter and antimatter were created in equal amounts, and they annihilate each other. All right, let's pause here for a second. If matter and antimatter were created in equal amounts, and they annihilated each other, then logically, a universe filled with matter shouldn't exist, right? There shouldn't be atoms, no stars, no planets, and we shouldn't exist either. But we do, and that's where the mystery begins. The mystery of why matter exists in a system that was originally supposed to cancel itself out has become one of the biggest questions in modern science. Because if matter and antimatter were created in perfectly equal amounts, then from the very beginning, matter shouldn't have existed at all. But here's the twist. The universe wasn't perfectly balanced. There was a tiny imbalance, and that imbalance is known as baryon asymmetry. According to existing theories and experimental evidence, scientists estimate that in the first moments after the Big Bang, for roughly every 1 billion pairs of matter and antimatter that annihilated each other, there was one extra particle of matter that didn't have an antimatter partner. It stood alone. And because it had nothing to annihilate with, it survived. Yeah, just one extra particle for every billion pairs. And from that single surviving particle, atoms eventually formed. Then they became stars, then became galaxies. And eventually, they became life as we know it today. And honestly, there's a deep irony in that. Everything in this universe that we see as beautiful, structured, and extraordinary may have come from a tiny imbalance.
Big Bang produced equal amounts of matter and antimatter, but as the universe cooled down, matter and antimatter annihilated almost perfectly, but not quite. For every billion particles of matter and antimatter, one was left behind. The little particle that was left behind, for every billion that annihilated, is what makes galaxies, stars, planets, and people.
Now, if you're asking why that imbalance existed in the first place, well, there are many theories trying to explain it. But to be honest, none of them have given a clear and definitive answer yet. For now, the most honest thing we can say is, we don't know. But whatever the reason may be, the point is this. We exist not because the universe was perfectly balanced, but because it deviated slightly from symmetry. Right now, after the universe has cooled down, the energy levels are no longer high enough to create large amounts of matter and antimatter. Antimatter can still appear under extreme conditions, but the amount is incredibly small, almost close to zero. And this is where we enter a real laboratory called CERN. Some of you probably already know about it. And yeah, CERN is also part of the story in Angels and Demons. Inside CERN, there's the most advanced, largest, and longest machine in the world, the Large Hadron Collider. It stretches about 27 kilometers and sits underground, crossing the border between Switzerland and France. In this facility, scientists accelerate particles to nearly the speed of light, then smash them into each other. From the energy of those collisions, pairs of matter and antimatter are created again. And in the movie, that antimatter becomes the core of the bomb the Illuminati plan to use against the Vatican. But can antimatter actually be used as a bomb? In theory, the answer is yes, it can. Because when antimatter comes into contact with normal matter, like something as simple as air molecules, they will annihilate each other, and all of their mass is converted into energy. According to E equals mc squared, the greater the mass, the greater the energy released. And this is where it becomes dangerous. If you plug in the numbers, for example, if you plug in just 1 gram of mass and multiply it by the speed of light squared, the result is about 90 trillion joules of energy. That's completely insane. 90 trillion joules is roughly equivalent to around 20 kilotons of TNT.
If I have 1/4 of a gram of normal matter meeting 1/4 of a gram of antimatter, then the resulting annihilation has the explosive force of 5 kilotons of TNT.
The energy from just 1 gram of antimatter would be even greater than the Fat Man bomb. But of course, it's not that simple to build an antimatter bomb, because creating antimatter is extraordinarily difficult. According to CERN, they can only produce about 1/1000th of a gram per year. That means we would need about 1 billion years just to get a single gram of antimatter. In other words, it's practically impossible. So large amounts of antimatter probably only exist in angels and demons. So that's our discussion about antimatter, guys. Something that almost wiped out the entire universe at the very beginning. And maybe the most interesting takeaway from all of this isn't about a bomb or explosions. It's about a tiny imbalance that actually mattered. The universe we live in today exists not because it was perfect, but because it was slightly off balance. And from that small deviation came galaxies, stars, planets, and even us. Reality isn't always neat. It isn't always symmetrical, and maybe that's exactly where its beauty lies.